Okay, my student will today we'll start talking about delta connected generator and delta system in general. Section 24.7. Here you can see the delta connection as we mentioned before in previous lecture. How to connect delta connection. We connect end with start for another winding and end for the second one to the third start or the third one, and end of the third winding to the start of first winding. You can see here we have similar to Y connection, we have line voltage and phase voltage. Phase voltage called EAN and line voltage EAB. Similar for phase B, phase voltage EBN, and line voltage called EBC. Finally, for phase C, ECN for phase voltage and ECA for line voltage. In delta connection, it is the opposite of from the Y connection. Here you can see the line voltage equal the phase voltage as a magnitude, okay, and the same thing as angle. And if you need to write sinusoidal expression, EAN, small letter EAN, you will multiply by root 2, multiply by magnitude RMS value sine omega t, because this sequence ABC, there is ABC sequence and which is positive sequence, and ACB which is negative sequence as we mentioned before. Because this you will find here EBN it's minus 120, ECN plus 120 between each phase and the other phase shift 120 degree. For the current in delta connection, the relation between line and phase current, you multiply phase current by root 3, you will get line current. Here IA capital A small equal root 3 IB capital A small. You can see here this line value IA capital A small. Okay, you need to multiply by phase value with the root 3. This is the phase value for the current. The phase value, which is the current going through the winding. Okay. The angle between phase and line value is 30 degrees. You need to multiply by minus 30 degree, and for line B capital B small minus 150. You will notice that between minus 30 and minus 150 it is phase shift 120 degree. Similar for IC capital C small, which is line value, multiply phase value by root 3 with 90 degree. Here you can see the phase sequence, section 24.8 delta connected generator, similar to Y connection as we mentioned previous slide. There is ABC and the value, the angle and the magnitude as mentioned as written here. For phase B, BC, our value for EBC minus 120, ECA plus 120. If you need ACB, only the change for sequence ACB, you need to change 120 to be 100 minus 120 to be 120 degree, okay, and for ECA it will be minus 120. Sorry for that. Okay, we'll go to next section, which is delta connection. We mean source, the generator is delta, the load is delta. Here delta Y system, the source will be delta and the load will be Y connection. For example 24.3, for the system shown in figure 24.2, which is this, find the phase angle, phase 2, theta 2 and theta 3 for the specified phase sequence. It is mentioned here, it is negative sequence ACB. You need to be careful when you solve the example. Since it is ACB, it is a negative sequence. As we mentioned in the previous slide, we will follow this. Theta 2 will be 120, theta 3 will be minus 120. As you can see here, for the solution for an ACB phase sequence, theta 2 120 and theta 3 minus 120. See? Okay. For B, find the current in each phase of the load. We need to find the current phase current, which is IAB small, IPC small, ICA small. How to find this? We need to find the phase voltage across impedance for each impedance, and then divide this voltage divided by this impedance. And you can see here the resistor is parallel with the capacitor. Okay, we need to find the value for this impedance, total impedance for each phase alone, and then divide the phase voltage, not line voltage. Here in delta, line voltage equal phase voltage, but if it is Y, you need to be careful. Your calculation must be applied by phase value. Here you can see 120, it is phase value. You will divide it by the Z here. You will get the phase current, as we see here. VAB divided by ZAB, which is 120 angle 0. How to find the total? How to find the total impedance for this winding? 5 resistor with the angle 0, 5 ohm with the angle minus 90. Divide by the summation, you will get the answer, final answer, 33.9 angle 45. This is for IAB. If you need to find IBC, the value will be the same, the magnitude, but the angle, which is difference between them. You will notice that between 45 and 165, 120 degree shift. If you continue solving, 120 angle minus 120 divided by the impedance, you will get 33.9 ampere and angle minus 75. For last question, for last part, find the magnitude for the line current. Now we need to find the magnitude. He asked about the magnitude only. You need to multiply the magnitude for the phase by √3. You will get line magnitude. See, 34, it's approximately 34, it's 33.9 multiplied by √3, you will get 58 ampere. Therefore which is equal IAB equal IBB IC capital C small. Okay, continue, same section, another example. Example 24.4. For delta Y system shown in figure 24.21, find the voltage across each phase. We need to find the voltage across each phase. Since we know that it is Y connection, the line current equal phase current, we can direct multiply the phase current with the impedance here, which is series resistor with the capacitor, and this is the value for the current line and phase. We multiply the value of the current phase with the impedance, from where we got 10 ohm angle minus 53. When we add these impedance, this impedance, okay, 6 ohm plus or minus J8, since it is capacitor, you will get 10 ohm by phasor form, 10 ohm angle minus 53. You will find the answer 20 and minus 53. Continue multiplying phase B, you will get 20 angle minus 173.13. Last one, 2066.87. Try to solve by yourself. Use the calculator to get this answer. Okay, to be easier for you to solve other question later. Part B, find the magnitude of the line voltage. We need to find the magnitude of the line voltage, this. Okay, since we have the magnitude here for phase voltage and this is Y system, then we need to multiply it by root 3. 20 by root 3, you will get 34.6. This is the magnitude. Okay, now we will talk about power section, which is last section in this chapter. Okay, we will learn here about active power, reactive power, active power, which is average power, and reactive power, and apparent power for Y connection and delta connection. In the beginning, we know that the active power or average power consumed in the resistor. Put this in your mind, always the active power consumed in the resistor. And we know that to find the active power, we need to multiply voltage phase by current phase. Be careful, phase with phase, with multiply cosine theta total, you can say. Theta V phase I phase mean the theta difference between them, which will be like this. Theta V minus theta I. Okay, this is single phase power, active power. Later we'll talk about three phase or total power, since we have three phase. Okay, you can use another formula, which is I square multiplied by R. Even there is inductor or capacitor in the phase, to find active power only you need to multiply I square by R, since we said the active power consumed in the resistor. Okay, or we can say VR square over R theta. Be careful about this, and the unit will be watt. Don't forget to write the unit for the active power. Right. If we need this single phase, as we said, if we need to find total power, you need to multiply the single phase by 3, since there is three impedance, three phase. Okay, only you need here there is active power, and here another active power, here third active power, because this we multiply 3 by power phase, power single phase. We have another formula for the total power. Either we can use phase by phase and multiply by 3, or we can use voltage line with current line, depend on the question and what is the information available. Okay, but don't multiply line by line and with the 3. No, multiply by root 3. Okay, and the same thing cosine theta, voltage phase, I phase, and this we will see this later, consider as power factor. The other way to use 3I square line multiply by R. Why we don't put root 3 here? Because the current line equal the current phase in Y connection, because this we cannot use root 3. And from where we got this formula, we derive this from this part. Okay, but the finally we need to know that we have two options to calculate the total power. Either multiply 3 by phase, voltage phase current with cosine, or root 3 voltage line with current line cosine theta. Now we will talk about active power and apparent power. Active power, which is Q, you need to multiply same thing, voltage phase, I phase, but not cosine. We need to multiply it by sine theta. Okay, or we can say I square phase by X. See here, reactive power we multiply by X, not R. Why we multiply by X? Because reactive power comes from capacitor, because the capacitor is source of reactive power, or absorbed by inductor, because this either here we will use XL or XC. Similar here, V phase square over X phase. To find the total reactive power, multiply 3 by single phase reactive power, you will get total reactive power. Finally, same thing, you can multiply root 3 by voltage line, I line, sine theta, V theta, phi, and I phi. For apparent power, similar to active and reactive, but without a sine or cosine. Only you can multiply phase by phase, voltage, phase current, and then multiply 3 by single phase power to get the total power, or you can direct multiply voltage line by I line with root 3. Finally, we need to know about power factor. The power factor, the formula for the power factor, either P total or divide by S total, or B single phase divided by S single phase, and also equal cosine theta. Okay, if you write power factor, for example, you say power factor 0.7. You need to write next of power factor either leading or lagging. Depend on the value of the circuit. Okay, if the current lead the voltage, you will write leading. If the current lag the voltage, you will write lagging. Okay, we'll start talking about example. We have some example we need to solve. Each example has different idea, and you need to go through a solved example here and after that try to solve exercise in the end of the chapter, and some question has answered in the end of the book. For this example, example 24.5, for Y connected load in figure 24.3, we need to find 4 parts. The first part, find average power to each phase and load and total load. How to find, what do you think, how to find the average power? What is average power? Which is active power, okay? We need multiply V phase by I phase if we have this information. Let us see how they solved. We have different options to solve. As we mentioned before, either multiply V phase by I phase cosine, and we have this information. From where we got 100, it is not mentioned in the question, but the voltage line mentioned, and this is Y connection. Divide 173 by root 3, you will get 100 as a magnitude, and the current we got, it is 20 ampere. From where we got 20 ampere? By dividing 100 by the total impedance. Here the impedance, the magnitude for the impedance is 5. If you use 5 ohm. If you calculate this 3 resistor and 4 inductor, you will find it is 5 ohm as a magnitude, not the angle. You need to calculate if you need to find the angle. And they divide 100 by 5, they got 20 ampere. 100 by 20 cosine 53.13, you will get 1200 watt. We have another option, as we mentioned before, either I square by R or V square divided by R. I squared, we said 20 by square, 20 square multiplied by R, which is 3 ohm, you will get 1200 ampere, similar to the first answer. You don't need to use these option to find the answer. One option is enough to solve, but this to prove that all the option will be correct. Voltage 60. This is voltage across resistor. We know that the total phase voltage 100, but across the resistor itself 60 volt. If you go here, you multiply 20 ampere multiplied by 3 ohm, you will get 60. 60 square divided by 3, 3600 by 3, 1200 watt. Now we need to find the total power. Multiply the single phase power by 3, you will get 3600. We have another option to find the total power. Multiply voltage line with I line. The I equal in the Y connection, but the voltage, we know that in the question it is 173 multiplied by root 3. This is the root 3. This is the root 3 multiplied by 173 multiplied by 20 multiplied by 0.6, you will get the same answer. Okay, we'll go to the part B. Determine the reactive power to each phase and the total reactive power. Similar, V phase, I phase, sine theta, 100 by 20 sine, see here sine not cosine, you will get 1600. Similar, I square by x, you get the same answer if you need the total multiplied by 3. Or V line, I line sine multiplied by root 3, you will get the same answer. Try to use the calculator to prove this answer. Make exercise by yourself for each answer. Part C, find the apparent power for each phase and the total apparent power. Voltage phase by I phase 100 by 20, 2000, multiply by 3, 6,000, or V line, I line, root 3, you will get direct 6,000. Last point, find the power factor for the load. Power factor, we know that it is active power divided by apparent power. 3600 divided by 6000, you will get 0.6 lagging. Lagging since the load here resistor and with the inductor. And if you divide single phase power by single phase apparent power, you will get the same answer. See, single phase 1200. If you divide it by 2000, you will get the same answer. Okay. For delta connection, you will see a similar formula for delta connection. For active power, same thing, phase by phase cosine, total multiplied by 3. For reactive power, phase by phase multiplied by sine, the total multiplied by 3. Apparent phase by phase, or root 3, 3 by single phase power, or root 3 V line, I line. Power factor similar E over S. We have here two example more. Yes, two example, and end with this chapter. See here, for please concentrate about this example. They have idea. See here, for the delta Y connected load in figure 24.25, find the total average reactive and apparent power. In addition, find the power factor for the load. Here, this circuit is combined between Y and delta, because this we need to find the power in the Y connection and the power in delta connection and add them. For active power, there is a resistor in delta, there is a resistor in Y. We will find this and this and add them. For reactive power, we have inductor in the Y connection and we have capacitor in the delta connection. We will find each one and subtract each one, because because the capacitor is source of reactive power and inductor absorb reactive power. We will subtract the value produced from the capacitor by the value absorbed from the inductor and find the total reactive power. First of thing, we need to find the total impedance in the delta. It is 6 minus J8, 6 minus J8, this. You will get 10 minus 53 degree. The I phase, E line divided by Z delta. E line, because delta connection line voltage equal phase voltage, then 200 divided by 10 equal 20 ampere. Power total, you will multiply 3 by I square R, 3 multiply by 20 square multiply by 6, 7,200, and the reactive power similar, 3 I square X theta. Here the X is 8. You will get 9,600 var. Okay. The apparent power, 3 by V phase, I phase. This means 3 by 200 by 20. You will get 12,000. Now we will go to part Y. Similar, we need to find the impedance in the Y connection. The impedance in the Y connection, you will add them, 4 plus J3, you will get 5, angle 36.87. Here the voltage line not equal the voltage phase, and we said our calculation or the I phase must be applied by V phase, which is EL divided by root 3. Is this value will be the phase value, voltage phase, divided by ZY, which is 5. The magnitude is 5. 200 divided by 3 divided by 5, you will get 23.1. Now we can multiply 3I squared by r, 3 by 23, multiply 23 squared, multiply by 4, around 6,400. Reactive power similar, but multiply by 3 since inductors 3 ohm, and the apparent power 3 by V phase I phase, you will get the answer. Now the total, since active power consumed in delta and y, add them. You will get the total active power 13,614 watt. But for the Q total, we subtract Q total delta minus Q total y. Don't memorize this, shabab. Not always Q total delta minus Q total y. It is capacitor or the greater one minus by smallest one. You can say the capacitor source. If the capacitor in the Y connection and the inductor in the delta connection, you will write the opposite. Okay. In the end, we need the answer for the subtraction between them. Since one of them source of reactive power, the second is the absorb, which is inductor, absorb reactive power. It is mentioned here 9,000 minus 4,800. The answer will be 4,789.19 var. How to find the apparent power total? You square each one, P square plus Q square under the root. You will get the answer 14,432. Divide active power by apparent power, you will get 0.943 leading because the effect of the capacitor greater than the effect of the inductor. So this will be leading. For last question, now we have question with the transmission impedance. Consider this source. This is the source, the load, and this transmission line. And the transmission line actually has impedance. Later you will see in course of transmission, you will study all these information. Let us read the question. Example 24.7. Each transmission line for the wire three-phase system in figure 24.26 has an impedance 15 ohm plus J20, which is this. The system delivers total power 160 kilowatt. This means active power. Okay, delivered. This means delivered in the load. Okay, not from the source. It is delivered here. This means there is some losses in the transmission line at 12,000 volt. This information you need to be careful about the voltage mentioned in any question of the three phase. How to decide this voltage, either line voltage or phase voltage? It is not mentioned here. It is 12,000 voltage to a balanced three phase load. Continue talking. If it is mentioned line voltage, it is considered as a line. If it is mentioned phase voltage, you will consider it as a phase voltage. But what about if he does not mention either phase or Y? In general, for all the book in electrical, if the voltage mentioned in the three-phase system connection, either for example motor, generator, transmission line, you will consider the voltage not mentioned, not specify which type. You will consider it as line voltage. Please be careful about this information. You will get a benefit from this information later. Other courses, any voltage not mentioned, not specified, you will consider it as line voltage. Okay, let us start. the parts. Determine the magnitude of the line voltage EAB of the generator. We need to find EAB in the generator. This means we need to find the voltage here across phase and the voltage across the transmission line, add them. We can make a single phase circuit as generator EAN phase, and here V phase for the load, and this as a single phase circuit. We know that Kirchhoff voltage law, EAN the source minus I theta Z line minus V theta phase equals 0. This means if we find V phase and we can find the current and multiply by Z line, you will find the phase value here. If you find phase value, you can find line value by multiply by root 3. This is what we need to do. In the beginning, see, it is Y connection, and they consider 12,000 as a V line, as we mentioned. Divide by root 3, you will get 6,936 volt. This is a V phase in the load, across the load. The power total, you multiply 3 by V phase, I phase, cosine theta. Cosine theta, it is mentioned in the question, the power factor, a balanced 3-phase load with a lagging power factor of 0.86. Since he mentioned lagging power factor, for example, I ask you what type of the load, what elements connected in the load, resistor, inductor, capacitor, resistor, inductor, resistor, capacitor. Okay, it is very clear from the mentioned here lagging. This means here each impedance has resistor and inductor. Okay, or resistor, inductor, capacitor, but the effect or the value of the inductor greater than the value of capacitor. Okay شباب, we found the total power now, and we know that we can find the I phase. We have this information, we have this information, we have this information, only the remaining I phase. B total divided by 3 V phase cosine theta, you will get 8.94 ampere. Now we got the I phase, which is I line, which is the current going through this impedance. If we multiply the current by this phase, you will get V Z line. Okay, sure. If we add this voltage and this voltage phase, you will get V phase in the generator. See here, cosine theta, it will be cosine inverse 0.86, it will be 30.68. V phase as angle, consider it as a 0 angle. Okay, lagging power factor. Then I phase will be 8.94 angle minus 30.69, if we assume that the V phase here angle 0. Now we have this value of I, which is equal I line. Now we can multiply here this value by the impedance. This impedance, if you add 15 plus J20, you will get 25 angle 53, and then we will add V phase, you will get the answer, voltage phase in the generator. Now still we did not find the answer. The question asked determine the magnitude of the line voltage EAB of the generator. We need to multiply this value by root 3. Okay, some part is missing, or this if we multiply by root 3 and angle 30, let me check in the book. Yes, in the book there is some part missing. If you multiply by root 3, you can open page 1110. You multiply by root 3, you will get the value of 12,358.26. Okay, for EAB. For part B, he asked us find the power factor of the total load applied to the generator. Applied in the generator. Okay, the total the power factor. This means we need to find power total. Okay, the power total which is given in the question, the load plus the power consumed in the transmission line. How to find this? You multiply 3I line square by R line, which is 15. Okay, you will get 3,596, and them. This means the total power source, the source total power, active power, it is 163 163,596. Okay. Now he asks you about the power factor, and we know that this is the formula, and we have this information now. We have V line, we have I line. We can find the power factor from the generator. Okay, this is the power, and this is the voltage line, and this is the current line, and this is the root 3. You will get the answer power factor 0.856. Okay, last part, what is the efficiency of the system? The efficiency of the system, we need to divide the output of the system divide by the input. To find any efficiency for any equipment or any system, you need to divide by power output, how much we got output from this input, and the output is very clear. Okay, which is given the question in the load 160 kilowatt. The input, which is B output plus B losses, where the losses consumed, this is here in the transmission line. Okay, which is 3,000 plus 160,000, and divide them, you will get the answer 0.978. This means 97.8 degree. Okay, this will conclude our chapter and our lecture. Thank you for listening, and if you have any question, ask us by email or by Telegram group.